Hi, this is Coach Dorf. We're going to now look at a homework problem from section 5.3, part 1. All right, so in this problem, we have this function g of x. So I'm going to write it here, g of x, it equals the integral from -3 to x of f of t dt. And the graph of f is shown there in red, and we're supposed to answer some questions about g. So this function g here is a little bit strange. It's not something we're normally used to. We don't think of an integral in terms of a function there, but it's perfectly fine to do this. So a couple questions to ask here. What varies in g? What's the variable? Well, the variable is x, and x is this part up here. That's what changes. So there's the variable. But our function also has this tt and this t here. And those are just called a dummy variable. And they could be anything we want. They don't have to be t. They just represent some placeholder there. I could make them a smiley face, a Christmas tree, a star, whatever I want. In this case, we're just using t, though. So what varies is x. And what does g represent? G equals the area under the curve y equals f of t, so that red curve above, and above the x-axis, and from -3 to some value of x. That's what it represents. Let's see if we can use that now to answer some questions. Evaluate g of -3. So that's the area under the curve from -3 to -3. So that's like, if I go to my graph here, that's right here. Here's x equals -3. In terms of an integral, it's going to be the integral from -3 to -3 of f of t dt. Well, if I think of this as area under the curve, I've got, when I use my definition like a Riemann sums, I've got a rectangle whose base goes from -3 to -3. So the length of the base is 0. So no matter what it is, the area under the curve is 0, because the area would be base times height, but the base is 0. So anytime you've got the same numbers on the limits here, the top limit and the bottom limit are the same, then that area is 0. There's no area under the curve because you haven't gone anywhere. All right, what about g of 3? All right, so that's going to be the integral from -3 to +3 of f of t dt. Well, if I look at the area from -3 to 0, I notice that, so the integral from -3 to 0 of f of t dt has the same numerical value, or the same amount of area as if I went from 0 to 3. The area here, so my curve looks something like this. This area here equals that area, call that area A1, and this area A2. They're the same amount. However, one's above the x-axis and one's below the axis. So we say that they're equal to the negative of the other. The amount of area is the same, but one is above the x-axis, so it's positive. The one below the x-axis is negative, so they're equal to each other, where they're equal to the negative of each other. So when I add those together, then I also should get 0, because the area from -3 to 0 should be a positive value, and the area from below the axis and above the curve from 0 to 3 is going to be the same numerical value, but it's going to be a negative of the other one. So when I add those together, I get 0. Now we're supposed to estimate the values for different parts of g. So the first one is g of -2. So that's going to equal the area under the curve, y equals f of t, above the x-axis, and from x equals -3 to x equals -2. And I can write that in terms of an integral as this is what that says. So that's the area here. Look at that. Well, what does that look like? That looks like it's about 1 or 1.5, 1, because I'd say it's about 1. I'm just estimating it though. It's about 1, because I've got this rectangle here of base 1 and height of 2, and it's approximately equal to that rectangle there. I'm going to say that area is about 1. But it's an estimate there. What about g of -1? So that's going to be the integral from -3 to -1 of f of t dt. So that's going to be the area under the curve. Let me use a different color here. Let me use green here. So g of -1. So it's the integral from -3 to -1 of f of t dt. So now I'm going to be adding this area in here plus this area there. So it looks like a triangle. That triangle there, the area, the base is 2, the height is 3. So 1/2 times 2 times 3 is going to give me about 3 or so. I'm going to say that equals about 3. All right, and then the last one here, we'll do in purple. We're supposed to do g of 0. So that's the integral from -3 to 0 of f of t dt. And what's that about equal to? So now I'm going all the way over here. So now I've got all this area there. And again, that looks like it's shaped like a triangle, a base 3 and height 3. So using the triangle formula, times 3 is 9, times 1/2 is 9/2. So about 4.5 is what I'm going to say. Again, these are estimates, but that seems a reasonable amount, much better than saying the value is -2 or the value is 17. All right, so let's go back now to, that answers part B. Part C, on what interval is G increasing? So again, I'm thinking G, think of G is area under the curve, y equals f of t, and above the x-axis. If I go back here and look at my curve here, or let me just draw a sample of it. It looks like this. There's y equals f of t. There's -3, there's 0, and here's 3, and we have -2, -1, 1, and 2. Well, where's the area where I want to find out where the area keeps increasing? Well, it increases as long as I go to 0. So I'm getting more area when I go to -2. I have area. When I go to -1, I'm adding more area here. When I go to 0, I'm adding more area. But as soon as I go past 0, I go below the x-axis, and now I have negative area. So this is negative area. And so my area is decreasing. The area under the curve y equals f of t is increasing from x equals -3 to x equals 0. All right. And then it starts, after that, it starts decreasing because it's going below the x-axis. So G is, so my answer to my question in part C, answer, G is increasing on the interval from -3 to 0. And then it's decreasing from 0 to +3. Letter D, where does G receive its maximum value? So G has max value at x equals what? Well, at x equals 0, because I'm increasing my area under the curve from -3 to -2, -1 to 0, and anything in between, any fractional or decimal representation in between -3 and 0. But as soon as I go past 0, I start decreasing because I have negative area. The curve goes below the x-axis. So it has a maximum value at x equals 0. All right, letter E says, sketch a graph of G here. And now I'm going to make a curve here. Let me do it here. So -3, -2, -1, 0, 1, 2, 3. I'm going to use purple to represent the curve. So what's the area? So G represents the area under the curve. So from -3 to -3, that area is 0. We saw in part letter B that G of -2 was about 1. All right, so we're going to put this is about 1. At G of -1, we saw that was 3, right? G of -1 is 3, so that's 1, 2, 3. And also we had that G of 0 was about 4.5, so that's about there. Now, what do I also notice? I also notice that the curve is somewhat symmetric. I look at it. It's a rotation of it. The amount above the x-axis from -3 to 0, it matches the curve from going from 0 to 3. So the amount above the x-axis is equal to the amount below the x-axis for the symmetric points. So the amount from -1 to 0 above the x-axis is the same as the amount from 0 to 1 below the x-axis. So what that means is I'm going to just start going down when I do this, and it's going to match a pattern here. And so my curve looks like this. And that's going to be my g of x function there. All right. And then the last part, letter F, says, use the graph in part E to sketch a graph of G prime. Compare this to the graph of F. So sketch a graph of G prime. So I'm going to do that down here. All right. So let's see, pink here. All right. So what do I know about my graph in purple that I did in part E, the graph of G? Well, I know the slope of the tangent line is increasing. It's increasing. It seems to have its maximum increase somewhere around maybe -1, and then it starts increasing less. And at 0, at x equals 0, then the slope of the tangent line is 0. So that at 1, it's about that. -2, it's about like that. So it's increasing. So the value, the slope, which would be how high I go up here, the slope is increasing. It has its maximum increase at -1. So it's kind of like this. And then at 0, the slope is 0. Right? That's what we have here. Slope is 0. And then the slope is negative, with the most negative part at about -1, and then it's getting less there. So it's kind of looking like this. So that would be the graph of G prime of X. How does that compare to F? So how does G prime compare to F? It's the same. They're the same. And why are they the same? That's the fundamental theorem of calculus part 1, because I'm having problems writing here. Because of the fundamental theorem of calculus, because it says that the derivative and integral are inverse operations. And so remember that G equals the integral from -3 to x of f of t dt. So what's G prime? That's the derivative of the integral of this. And so I have a derivative, and then I have an integral, and they undo each other. And so I'm going to get back f of x. That's what the fundamental theorem of calculus says. All right, hope that helps.